notice it says give exact answers, and so I really don't think at any point you're going to really need a calculator on this one. If you were going to give decimal approximations, you would, but since it says exact answers, I will say I think I've probably been around to see. Hey, Hosanna. Sorry to interrupt, but we're going to move forward. I think I've seen about half of you guys work here, and I think it's either perfect or it's very close. It's very, very good on this one. So remember, your first step on something like this is try to get the perfect square quantity isolated. It already is. So once you have that, we're going to get rid of that squared by square rooting. So that really should have been your first step, and I think I saw that on just about everybody's. Once you've done that, the squared and the square root cancel each other out, and you are left with 2x minus 4 is equal to plus or minus root 7. You guys are doing a much better job of handling that plus minus symbol today, so that's really good. And then the final steps would be to solve, and so we're going to add 4 to both sides. So plus 4 here and here. This gives me 2x is equal to 4 plus or minus root 7. Then dividing by 2 gives me x equals 4 plus or minus root 7 over 2. And that would be a really good answer. The only thing that I saw from here that was an issue is some folks said x is equal to 2 plus or minus root 7. And I was able to kind of help with that a little bit. Do you see why that would be wrong? Yeah. I'll point it out. Do you see how they've only divided the 4 by the 2? And it's the whole numerator that should be being divided by 2. So if you wanted to do it that way, if you just put this root 7 over 2, that would still be numerically correct. And you could leave it like that as well. Do you guys have any questions? Anything at all? Okay, we're going to do one more sort of like this, and then we'll get back into that complete the square that we were doing yesterday.
Senior Brooks just with me every single day.
Senior Brooks. No, last week. I wore some shorts.
So did I.
You know what?
Yeah, I wore sweatshorts.
All right, there you go. Said I'm going to record this. The answers that I saw were quite good. First step here, remember the goal is to get the perfect square expression isolated first. And then we can deal with it from there. So I'm going to add 12 to both sides. That gives me this. Again, I think it's really important to keep in mind the goal. The goal is to get the perfect square expression by itself. It's still not by itself, but if I divide both sides by 4, now it is. So it'd be x minus 7 quantity squared equals 3. Now that the perfect square quantity is isolated, I can get rid of it by square rooting. This gives me x minus 7 equals plus or minus root 3. And if I add 7 to both sides, I get x is equal to positive 7 plus or minus root 3. And since we're doing exact answers on this one, you'd leave it as is. So, any follow-up questions on that? It's our third day doing this. I'm hoping it's starting to settle in. But if there's any, it could even be like one little minor question like, hey, I always thought it was this. Now you did it like that. Whatever. Could be something small, could be something big. I don't know. We good? Okay, let's see how this goes with completing the square. So we're going to switch gears a little bit. Okay, here we go. Same instructions, solve, give exact answers. Let's go with there we go. To give you a hint here, you will have to use completing the square. Factoring will not work. So please, I guess you can try it if you want, but I think you'll find that it doesn't work. You guys are remembering this rather well. But a question was brought up, and I think that it's a good question for us to all think about, because I feel like there's a potential for later on. If you don't think about this, you might confuse yourself and be like, whoa, we never talked about that. So here was the question. The question was essentially, hey, wait a minute. I thought that with these quadratics, we always wanted to have everything on one side equals 0, right? And so I want to clarify that. I would say that in general, yes, but when I say in general, here's what I'm talking about. If the quadratic is factorable, like you can factor it, then you want to do what you're talking about. You want to set the whole thing on one side equal to 0, factor it, and use the 0 factor property. If it is factorable. So check this out. When you look at this, and maybe, if this were just a random quiz or test question, you might think about factoring, right? Do you see how somebody could be like, hey, I know how to do this, I'll just factor it, right? Yeah? So, if you tried that, you'd say, all right, well, my AC is -4, my B is 10. Which numbers multiply to be a -4 and at the same time add to be 10? And you can think about it as long as you want, but you're going to come up empty, right? There are no such numbers. So what that means is that this quadratic, as it's currently written, is not factorable. And so because it is not factorable, now hey, we want to set everything, get everything on one side equal to 0. That's not going to serve us very well. That only serves us well if we are going to be able to factor it. And later on, we'll find out if we're going to use that quadratic formula thing that we've hinted at a little bit. That's also a scenario where you want everything on one side equal 0. But if you're going to use this complete the square, that's not going to work. So it really is a practical consideration. That old strategy doesn't work because this is not factorable. So you've got to take a different strategy, different approach. So that is complete the square. And I want to remind you guys of the steps here. I'm going to write these off to the side. The first 2 steps rhyme. So step 1 is move C. And so that would be +4 to both sides. That would give us x squared plus 10x equals 4. Notice I left that space. Step 2 is square half of b. Notice it rhymes, move c, square half of b. So to square half of b, we need to identify it. B is equal to 10. Half of b is equal to 5. And if you square the results, you get 25. And then the question that came up a couple times. I thought it was a really good question. Great. I moved c. I just squared half of b. I got 25. What on earth do I do with the 25? What do you do? Okay, you put it where C was, right? I agree. So you put it right here.
Add it to the other side too.
And yeah, so you add it to both sides, right? So you add it in where the C was, and you have to add it to the right side also. Okay, so then now we have a new equation. This equation is now totally factorable. In fact, it is a perfect square factoring, which allows us to use that square roots property that we practice so much. We've been practicing all morning. So this factors as x plus 5 quantity squared. 4 plus 25, of course, is 29. Grace?
Okay, you just said if it's not factorable.
Okay, hang on. Let me finish. I'm doing good, right? I've got some momentum. Let me come back and answer your question, okay?
Yeah.
So we square root this side, we square root that side. We get x plus 5 is equal to plus or minus root 29. We subtract 5 from both sides. So we get x is equal to -5 plus or minus root 29. Good? Now let's go back to your question. So you said, but wait.
At the beginning you said if it's factorable.
Then you want to set it equal to 0. Okay, yeah.
This is factorable.
Okay, now check this out. Let me write an extra step here. Let me show you why we have to use the technique. This is just a different technique. I have an analogy, but I'm not going to use it right now. Okay, so we got x squared plus 10x plus 25 equals 29. So if you take that approach you're talking about and you say, hey, that's a quadratic, and I want to have everything on one side equals 0, well, then that's actually pretty darn simple to get it there. Don't I just need to subtract 29 from both sides? Okay, so minus 29 minus 29. This gives me x squared plus 10x minus 4 equals 0. Have you seen that anywhere before?
Oh wow, that's right at the top. Got it.
So I did all that work with my move the c, square half of b routine, and then by subtracting 29 from both sides, I've completely undone that, right? So then you come back to this and you say, hey, cool. Now I'm going to factor this. Oh, wait, I can't. Do you see the never-ending circle, like logic circle that you'll get yourself into?
Yeah.
So then, you could drive yourself crazy doing this. You're like, oh, I need to complete the square. So move C, square half of B. All right. Oh, look. That left side factors. I better make sure it's set equal to 0. You see how you could drive yourself insane doing this?
Yeah.
You're just going around and around and around. So Grace, here's the point. Get this. If the original quadratic, set equal to 0, and like, this is beautiful right here, isn't it? I mean, that's perfectly beautified. I mean, that's just like what we saw in Unit 6, 7, and 8, right? If you've got something like that, and you're like, cool, I'm going to factor this thing and solve it. It's going to be great and super easy for me. And then you realize, wait a minute, I can't factor it. It's not factorable. It's not a question of your ability, just not factorable. You're going to have to use a different technique, one of which is the quadratic formula, which we'll get to in the next couple of days. The other which is this complete the square. So the complete the square is a different process. So when something was factorable, you could factor it and set each factor equal to 0, right? The whole point with the whole equal 0 thing, and solve. This is not factorable, so that strategy does not work.
So when it's this way with this new thing,
Mm-hmm.
it doesn't have to be set to 0?
No, in fact, you have to get the C to the other side. Right? The first step is to move C.
Yeah.
So I think the answer to your question is yes. In this case, we don't want to set it equal to 0.
Okay.
Because we want to use the square root property that we learned in 9.1. The square root property applies nicely to perfect squares. Grace, here's the truth. I illustrated this for you guys last time. You can use this, like this quadratic formula, this complete the square method. It will work on any quadratic. Can I give you a nice example?
Yes.
So this will work on any quadratic. The factoring, so maybe this would be the better way to put it. Factoring is a very narrow niche kind of technique. It only works on quadratics that factor. That's all it works on. So this complete the square works on any quadratic. So let me give you an example like this. Let's say we had x squared minus 7x plus 12 is equal to 0. This is, so like if it just said solve, you actually would have a choice of methods here. You could solve this by factoring. The factoring would be x minus 3 times x minus 4 equals 0. So you could do this. Check this out. This would be just fine. You get x minus 3 equals 0, x minus 4 equals 0. So you get x is equal to positive 3, x is equal to positive 4. Yeah?
Yes.
Okay. Maybe you didn't recognize that. Maybe you looked at this and you just had one of those brain moments where you're like, I just don't see it. I don't see the factoring. I don't think this factors, and so I need to use a different method. So if you're going to use a different method, what you would do is you would complete the square. So you would move C. And, I picked a really bad one here. You're not going to like these numbers. Half of B is negative 7 halves, so don't worry about this. I'll keep the B's even for you. So half of B is negative 7 halves. Squared is 49 fourths. So you'd actually add 49 fourths to both sides plus 49 fourths like so. So you'd get over here x minus 7 halves. Sorry, I picked one with an odd. This would equal 1/4. You can square root both sides then. You end up with x minus 7 halves is equal to plus or minus the square root of 1/4 is 1/2. This is all going to work out nicely because you're going to get x is equal to 7 halves plus or minus 1/2. You're going to get the exact same answer. The point, Grace, is this. You're trying to use the factoring technique on everything, and not everything factors. Does that make sense or does that not make sense?
No, that makes sense.
Okay. So that's kind of your decision point. Like if you look at it and you think to yourself, I don't think that factors. I think it's one of those ones that doesn't factor. Then one of the methods you could use is this complete the square. If you look at it and you're like, hey, that factors. I know it factors. And you factor it and you're done. Well, then why would you use complete the square? I don't think I would. I guess you could. I don't think it's that hard to do, but probably be easier just to factor it. Does that make sense? Gee,
yes.
it does. Okay.
Yes.
So I've explained you to a point of sleep. I'm sorry, Grace.
No.
You're tired?
Yeah.
Okay. All right, that's fine. That's fine. Hey, let's head back up to the board. Let's do some more practicing.
Hollister's at that concert.
Josh in the area.
Is he actually there? Was Josh actually there?
Okay, ready, go. Hey, gentlemen. Stop. Thank you. Again, to make sure that somebody watching this video is going to be able to understand this, let's realize this doesn't factor, and so we're going to have to complete the square. The way we do this is we move C. We move C by adding 3 to both sides. So this would be x squared minus 4x equals 3. I personally always leave that little space there because I know what I'm about to do. First step was move C. Second step is square half of B. So B is negative 4. Half of B is negative 2. And then the squaring of that result is 4. What do I do with that 4 after I go through all that work? Yay, there it is. Add it to both sides. So then that gives me x minus 2 squared when I factor equals 7. As I walked around, this was one of the struggles. Some folks had x plus 2 squared right there. Just keep in mind that you want to, fully factor that. Or you can use, remember that little half of b trick that I showed you yesterday? You can think about that too. Regardless of how you get there, now is the time to square root both sides. X minus 2 equals plus or minus root 7. So then x is equal to positive 2 plus or minus root 7 when you add the 2 over. Okay. You're doing well. Do you have any questions? We got time for another 1 or 2 to practice here, and then that'll be it. Okay, head back up to the board. Good job.
That was lame. I thought it was gonna be way louder.
Oh, but you dropped it like perfectly flat.
Yeah, you need to drop it sideways.
Here, will you get the bottom half? I got the top. Or okay. No, I'm just kidding. I can't reach it. I can't reach it. Can you
It's so fun. When we take she has an Xbox.
Jake, Cole's like, that's why Jake got so so bad.
I think the game is stupid.
Okay, guys, we're going to finish and do one last one.
Are you sitting or is this
You want to know the funny thing about that last one, Lana? It factored. Like originally, it would have factored. Oh, yeah.
Oh, you tricked us all.
I didn't trick you on purpose.
So, like, the system of doing it the other way.
So, like, this is the way we did it, right? So you end up with negative 2 plus or minus 3, which is the negative 5 or 1. But what you could have done, this would have worked really well if you would have said x squared plus 4x minus 5 equals 0. Ends up being x plus 5 times x minus 1 equals 0. And then you could actually use the zero factor property and solve. So this one could have gone either way.
Thank you.
Yeah,
Have a nice day.
you too.